Welcome to ClickMyProject.com. Now we are going to discuss about the project Pediatric Seizure Predictions in Scalp EEG using a multi-scale neural network with dilated convolutions. Now we are going to discuss about the abstract of the project. EEG is a most commonly used signals to detect the pediatric seizures. A new scheme of epileptic seizures detection using a wavelet is presented in this project. Hence, firstly, the original input EEGs are applied to the filtering method to remove the noise from the signals. From that, the signal is transformed into one categories like alpha, beta, gamma, theta and delta. These are the wavelets we have applied in the pre-processed signal. Then the features are extracted by means of the convolutional neural network, that is a kind of a deep learning method. The feature vectors are extracted to generate the test features from the signal. After generating the test features, then the classification steps is used to classify whether the signal is normal or abnormal. If it is an abnormal signal is present, means the message box will be displayed as an abnormal signal. The seizure classification is done by means of the machine learning classifier to classify the signal abnormality. Finally, the performance of the process will be evaluated to identify the efficiency of the process. In this process, we have evaluated the accuracy to identify whether the classification is working properly or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. This project consists the steps like input signal, pre-processing, transformation, feature extraction, feature matching, then finally performance estimation. These are the models we have done in this project. At first, the input signal is taken from the dataset. The dataset is the folder which consists of the lot of signals which having both the normal signal as well as the abnormal signal. After getting any one signal from the dataset, we just move to the pre-processing step. In this pre-processing step, we are going to do the noise removal as well as the signal limitation. So noise removal is applied to reduce the noises present in the signal, as well as the signal limitation is done to reduce the length of the signal. If the length of the signal is too much longer, means the length of the signal will be reduced in this step. After doing the pre-processing, we just move to the third step of the project, that is the transformation. So in this transformation, we are going to transform the input raw EEG into one alpha, beta, gamma, theta and delta signals. After doing this kind of transformations, we have to extract the features by means of the convolutional neural network. In this step, we are applying the CNN to extract the features. Then we have to generate the test feature from the alpha, beta, gamma, theta and delta signal. After generating the test feature, we are going to do the feature matching, that is nothing but the classification by means of the multi-SVM classifier. So in this classification step, we have to give three things as an input. One is the test feature we already taken from the CNN. After that, we have to import the train features and labels. These are the three inputs we are going to do the classification. Finally, after doing the classification, we are going to apply the performance estimation. So in this performance estimation, we have three kinds of performance parameters which having the accuracy, sensitivity and specificity. By these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main_GUI.yum and select the option run. Once you click the option run, the new user interface will be open. In that user interface, you can see the several push buttons in the right hand side for the controlling purpose, and then the axis and tables are in the left side for the display purpose. First of all, we have to select the button input signal. After clicking the button input signal, there are a lot of signals are displayed here. So in that dataset, we have to select any one signal from the dataset. After the selection of the signal from the dataset, the corresponding signal will be shown in the axis 1 with the title of input signal. Then we just move to the next stage of the project, that is the pre-processing. So in this pre-processing, after clicking the button pre-processing, the pre-processed signal will be shown in the axis 2 with the title of filtered signal. Here this is the sample frequencies of the filtered signal. After doing the filtering method, we just move to the transformations. So after clicking the button transformations, the signal is transformed into one alpha, beta, gamma, theta and delta. These are the plottings which represents the alpha, beta, gamma, theta and delta. Those values are plotted in this table. After extracting these 5 signals from that raw signals, we are going to do the feature extraction. So in this feature extraction, we are going to apply the convolutional neural network to extract the features. Then the corresponding feature values are shown in this table. You can see the results of the features value. This is the kind of a test feature we have generated by the convolutional neural network. After doing the feature extraction, we are going to apply the classification. So in this classification steps, it will first of all classify the signal ID. We have selected the signal ID as 34. After doing the classification, we are going to do the prediction. So once you click the button prediction, the prediction result will show us whether the input signal is normal or abnormal. Whether it is a normal, it will shows the message box as normal. Whether it is an abnormal, it will shows the message box as abnormal. Here we are took the signal which is having the abnormal signal. It is represented here. After doing the prediction, we just move to the final stage of the project, that is the performance estimation. So in this performance estimation, we are evaluated the performance parameters like accuracy, sensitivity and specificity. Those values are shown here as well as plotted in this bar chart format. Thanks for watching this video.